Welcome back to the deep dive. Looks like we're diving deep into Kubernetes scheduling today. All about how pods and nodes interact, huh? From what I can see, you're really interested in node selectors, node affinity, taints and tolerations. Those can be pretty powerful. They can definitely make or break your deployments, that's for sure.
Yeah, for sure. You're absolutely right. Those are really key in multi-node clusters. And it looks like you found Abhishek Viramala's suggestion to practice with kind or K-third. Those are great tools for that sort of thing. Way more cost effective than spinning up a cluster on a cloud provider like EKS if you're just experimenting, I
Oh
mean.
yeah, for sure. I can't tell you how many times I've seen people get hit with these massive cloud bills, all because they weren't comfortable enough to practice locally first.
So when it comes to multi-node Kubernetes, what are some of the common pitfalls you see people run into when they're first starting out? Well, a lot of people just assume scheduling is a set it and forget it kind of thing. But especially with complex applications, you really need to think about how your pods are going to get distributed across your nodes. Like you've got to think about things like their resource requirements, node availability, and even what happens if a node fails.
So it's more than just getting those pods up and running. It's about placing them strategically for performance, resilience, all of that. Speaking of things going wrong, let's say I'm trying to deploy an application, but my pods get stuck in pending. I know Cubicle Describe Pod can give me some clues as to why, but what are some of the more advanced troubleshooting things you do when those basic commands aren't enough?
Yeah, so Qvectal Describe Pod is great. It's a good place to start, at least. Sometimes, though, you really need to dig a little deeper, like you can actually go and analyze the scheduler logs, see why it's making the decisions it's making. Or you can even look at events with Cubicle Get Events and see if there are any events related to scheduling that might be causing problems.
It sounds like it's really important to not just know the commands, but to actually understand how the scheduler is making decisions, the whole process behind it. So let's talk about actually influencing those decisions. I see we've got some stuff here about node selectors. How can we use those effectively without making our deployments too rigid?
The trick with node selectors is to use them strategically, only when you have a very specific need. Don't use them as a general placement mechanism. Think of them like labels that tell the scheduler, hey, this pod needs this specific hardware or software to run. Like Apishek's example of a pod that needs an ARM processor, that's a perfect use case.
Right, but I've seen people try to use them for everything.
Yeah,
And that seems like it could cause more problems than it solves.
yeah, if you go overboard with node selectors, you can really back yourself into a corner. Like imagine you've got this big cluster
Yeah.
with all sorts of different types of nodes. And you've used node selectors to very tightly couple each application to a specific node type. Now, what happens if one of those node types goes down for maintenance or something? Your whole deployment could just grind to a halt.
It's about striking a balance then. Specificity so your pods land where they need to, but also flexibility in case something changes in the cluster.
You got it. And if you find you need more fine-grained control than what node selectors can give you, that's where node affinity comes in.
Node affinity. Is that where we get into those preferences we were talking about before? Like wanting a window seat on a plane, but being okay with an aisle seat?
That's a pretty good analogy, actually. Node affinity is all about preferences, not hard requirements. So instead of saying this pod must run on a node with label X, you can say this pod prefers to run on a node with label X. But if it ends up on a node with label Y, that's all right too.
So how does that actually work in practice? Can you give me a real-world example where you might prefer one node type over another?
Let's go back to Abhishek's example of a pod that prefers to run on a Windows node. Maybe you've got an app that runs a little bit better on Windows, but it can still function on Linux if it needs to. Node Affinity lets you express that preference to the scheduler without making it a hard requirement, so it still has some wiggle room.
So it's like giving the scheduler a little nudge in the right direction without tying its hands completely. That makes sense. Now, what about these required during scheduling, ignore during execution, and preferred during scheduling, ignore during execution things? They sound a little intimidating, to be honest.
Huh, yeah, they're a bit of a mouthful, but they're not as complicated as they sound. Required basically acts like a node selector. It's like saying, this is non-negotiable, the pod needs this to be scheduled. Preferred is more like a gentle suggestion. This would be nice, but don't worry if you can't make it happen.
So required is drawing a line in the sand, and preferred is more like, hey, if you could, that'd be great. I'm starting to see how all of these pieces fit together. We can really build a dynamic and resilient cluster with these tools. But what about when we need to tell the scheduler, hey, keep these pods away from these nodes? That's where taints and tolerations come in, right?
You got it. Taints let you mark nodes as undesirable for certain pods. Gives you even more control over where things end up.
So instead of focusing on where pods should go, we're focusing on where they should not go. When would you actually use taints in a real production environment, though? I imagine it's not something you do every day.
That's true. You don't use taints for just anything. You usually use them in specific scenarios. Like, let's say you're doing maintenance on a node, and you need to temporarily block new pods from being scheduled on it, or maybe you've got a node with some performance issues, and you don't want resource-intensive pods landing on it.
So it's like putting up a detour sign in your cluster, steering traffic away from potential problems. But I imagine there are different levels of keep out, right? It's not always an absolute no-go zone.
Yeah, there are. There are different levels of taint severity. That's where the no schedule, no execute, and prefer no schedule effects come into play. No schedule means that no new W pods can be scheduled on the node, but the ones that are already there can stay. No execute, though, that's like an eject button. It tells both new and existing pods to find somewhere else to go.
Wow, no execute? Sounds pretty serious. I can see how that would be useful for an emergency, but probably not something you'd want to use all the time. What about prefer no schedule? Where does that one fit in?
Prefer no schedule is the most lenient of the bunch. It's basically saying, hey, scheduler, try to avoid putting pods here if you can. But if you absolutely have to, it's not the end of the world.
So it's like saying, this isn't the best neighborhood, but it's not a complete war zone either.
Yeah.
Okay, so we've got these taints in place, and we're basically cordoning off certain areas of our cluster.
Yeah.
What happens if we have a really important pod that absolutely needs to run on a tainted node? That's where tolerations come in, right?
Exactly. Tolerations let specific pods bypass those taint restrictions, so you can control which pods can and cannot be scheduled on tainted nodes. It's like giving them a VIP pass to get past the bouncer, so to speak.
Exactly, like having the right credentials to get past the velvet rope.
Okay, so how do you actually set up these tolerations? Is it super complicated? No, not at all. It's actually pretty easy. When you're defining your pod, you just add a tolerations section to its config. In that section, you specify the key, the value, and the effect of the paint that the pod can tolerate. It's like giving the pod a map of all the keep out signs it's allowed to ignore.
So it's all about matching up the taints info with the tolerations info, basically.
Yeah.
But what if a pod has multiple tolerations? Can it handle different taints on different nodes?
Absolutely. Each pod can have multiple tolerations. And they all work independently, so it can be scheduled on any node where at least one of its tolerations matches a taint on that node. Like having a bunch of keys on your keychain, you just need one that fits.
Wow, this is really giving me a sense of how granular you can get with Kubernetes scheduling. It's like this really complex dance with pods moving between nodes based on all these preferences and rules. But with all this complexity, I'm sure there are things that can go wrong.
Yeah.
What are some of the common mistakes you see people making with taints and tolerations?
One common mistake is applying taints too broadly, or forgetting to remove them when you don't need them anymore. Like, let's say you paint a node during maintenance, and then you forget to remove it after you're done. That node could just stay off limits to new pods forever.
Whoops, like accidentally locking yourself out of your house. Speaking of things going wrong, let's talk a bit about resource management. We've been focusing on how pods can be directed to specific nodes. But what happens when you have multiple pods all trying to use the same resources on a single node?
Well, that's where resource requests and limits come in. Each pod can define how much CPU and memory it needs to run properly. The scheduler uses that information to make sure a node has enough resources before it puts a pod on it, like making sure there are enough seats in a restaurant before you let in another group of people.
So it's not just about matching labels and tolerating taints. It's also about making sure each pod has enough room to breathe. What happens if a node is overbooked, though? Like, what if the pods on a node are requesting more resources than it actually has available?
Yeah, ideally the scheduler would prevent overbooking from happening in the first place. But in reality, things can get a little messy sometimes. If a node does run out of resources, Kubernetes has ways to handle it, like evicting pods or throttling their resource usage. But those things can obviously impact the performance of your applications.
Makes sense, like trying to cram too many people onto an elevator. Someone's going to get squished. So managing resources effectively is key to keeping our cluster healthy. Are there any other advanced scheduling techniques we should know about?
We've covered the core concepts for sure, but there are definitely some more advanced things you can do, like pod affinity and anti-affinity. Those let you define rules for co-locating or separating pods based on their labels. It's like saying these two pods are best friends and should always hang out together, or these two pods are sworn enemies and should never be seen in the same room.
So we're basically defining social relationships between our pods now. Pod affinity brings them closer together, and pod anti-affinity keeps them at a safe distance. When would you actually use these techniques in the real world?
Let's say you've got a web application that uses a caching service. You might want to keep the web server pods and the caching service pods on the same node to minimize network latency. That's a good use case for pod affinity. On the flip side, if you have two pods that are competing for the same resources, you might use pod anti-affinity to spread them out across different nodes so they don't step on each other's toes.
It's like strategic urban planning, but for your cluster.
That's a great way to put it. The more you think about those relationships and dependencies, the more efficient and resilient your cluster is going to be. It's all about creating this balanced ecosystem where everything can work together harmoniously.
It sounds like Kubernetes scheduling is both an art and a science. It's not just about knowing the commands. It's about understanding the nuances and the trade-offs. What advice would you give to someone who's just starting out with Kubernetes scheduling?
I'd say don't be afraid to experiment. Set up a local cluster using something like Kind or K-third, and just play around with different scheduling configurations. The more you practice, the more comfortable you'll get.
That's great advice. Like learning to ride a bike. You're going to fall a few times, but eventually you'll get the hang of it. Speaking of which, we've covered a lot of ground in this deep dive on Kubernetes scheduling. Any final thoughts or key takeaways you'd like to leave our listeners with?
The biggest takeaway is that Kubernetes scheduling gives you a ton of control over how your applications are deployed and managed. But like with any powerful tool, it's important to use it wisely. Understand the concepts, experiment with different techniques, and never stop learning.
It sounds like there's always something new to learn when it comes to Kubernetes scheduling. Always room for improvement, always new things to try. But with the right knowledge and tools, we can build a cluster that really fits our needs. Not just functional, but optimized.
Absolutely. And it's important to stay up to date too. Kubernetes is constantly evolving, new features and improvements all the time. What's best practice today might be outdated tomorrow.
Continuous learning is key then. Can't just get comfortable and stop there. Gotta stay curious. Before we wrap up though, I'm curious to get your take on what the future of Kubernetes scheduling looks like. Any exciting new trends or technologies you're keeping an eye on?
One area I'm really interested in is the development of smarter schedulers. Like, people are working on using machine learning and other fancy techniques to create these schedulers that can adapt to changing workloads on the fly and optimize resource allocation in real time.
So instead of just relying on static rules and configurations, we could have schedulers that are constantly learning and adjusting to make the most of our cluster resources. That sounds pretty amazing.
It is. Another thing to watch out for is how serverless is getting integrated with Kubernetes. As more people move to serverless architectures, we're going to need even smarter scheduling to handle both containerized and serverless workloads seamlessly.
It's incredible to see how all of these technologies are coming together, shaping the future of cloud computing. We're getting to a point where we can deploy and scale apps with so much flexibility. It's really exciting. But with all this power comes responsibility, right? As Kubernetes scheduling gets more sophisticated, what are some of the ethical things we need to be thinking about?
That's a great point. As schedulers become more autonomous and intelligent, we have to make sure they're making decisions that are fair and unbiased, aligned with our values. We don't want to accidentally create systems that reinforce existing inequalities or create new ones.
It's not just about efficiency then. It's about building systems that are responsible and ethical. A reminder that technology isn't neutral. It reflects the values of the people who create it.
Exactly. We need to be having these conversations about ethics, especially as we get deeper into Kubernetes scheduling, making sure the tools we build are used to make things better for everyone.
That's a great note to end on. This has been a fascinating deep dive into Kubernetes scheduling. We've learned about node selectors, node affinity, taints, tolerations, resource management, even got a glimpse into the future of scheduling with intelligent and serverless aware systems. But the biggest takeaway for me is that Kubernetes scheduling is always evolving. So stay curious, keep experimenting, and never stop learning.
I agree completely. I encourage everyone listening to check out the resources we mentioned, set up a local cluster, and just start playing around. You'll be amazed by what you can do with Kubernetes scheduling.
And that's a wrap for another episode of The Deep Dive. We went deep on Kubernetes scheduling today, explored all the complexities and the power. Hope you all learned something new and are feeling inspired to continue your Kubernetes journey. Until next time, keep those clusters humming.